Hi everybody, welcome to part 3, which is probably going to be the final part on this restoration of this Precision Model 200. And I did a little bit of preliminary work. I got the probe cleaned up and put the wires back in. I installed, if we look here, I wired up these resistors for the attenuator circuit, which is 1-to-1 or 100-to-1, and I connected the potentiometer. I did put a grid stopper resistor in here, although it was pretty stable. There was no oscillations or anything like that. Just to be safe, I put a 1K resistor in there. It's not going to hurt anything. The rest of this is all wired up, and essentially I kept all this the same, but I just cleaned up the wiring on the socket. It was pretty bad, and I'll show it to you. So I put a new piece of silicone ground wire with a new copper clip on it, and I re-soldered the terminals of the socket and insulated them, and I also did the same insulating treatment on these wires here to make sure they're good. And these are really high temperature as well. They can take a lot of heat, which is another good thing, because these are going to be right against this tube here. In addition, the capacitor, if you remember, for the probe tip was missing. It wasn't with this, that 47 picofarad cap. And so I put a 47 picofarad, had to do a little bit of thinking about it, but I put it in there and heat shrunk it so that it's all insulated and it's very strong, and it connects right onto here. And it also connects, and then we also have the output here, which is our high voltage wire. So you can see they're all insulated. The ground wire was good, so I left it alone. And I think this is ready to go. Now, two things. We still need to have a housing for this. And you can see how big this thing was. Here, this is a 1-inch diameter stopper that goes into the back of the the tubular piece. And I'll show you something that looks similar to it that I have. So I have this really high-end VTVM by HP, and it's a model 410C. And for the AC probe, it actually has a probe that looks like this, and it's the same thing. It actually has a vacuum tube inside of it, just like this. And you can see it's kind of big diameter, and you can unscrew it. I'll show you, and there's actually a vacuum tube inside there. A little bit different than the one that we have. This is a special one that's used for high frequency AC. This thing will go up to, I think, 600 megahertz or some ridiculous thing. Or 300 megahertz, I can't remember. But anyway, this is also an active probe that does a similar job, but it's for actually measuring voltage levels. So it's calibrated for the meter. Whereas what we have is much simpler. It's just being used as a detector and just a little bit of amplification. So it's not as critical, but it's the same idea. So we're going to need about a 1-inch diameter piece of tubing to fit this. And then I do not have the end that holds the tip, but I have an idea for that. So I have this. It's a big long piece of just aluminum tubing, and I'm just going to use a regular pipe cutter, my pipe cutter, to cut this off to length. And we have the stopper for this end, but the end with the tip we're going to have to turn on the lathe. So I'll have to go down to my wood shop, and I have some really high quality plastic. It's very strong, very durable. And we're going to make a new tip for this, and then I'm going to use just a piece of really thin, like 1/8 inch brass rod for the actual probe itself that comes out of the end. So we're going to do that, and that should have this just about finished up. Now, I did have to change 2 more things. In order to get the voltages where I want, after adding that 6C4 tube, remember, as we said, anytime you make changes to these unregulated circuits, the voltages can change because of these resistive droppers. So I had to change this 27K down to a 10K. I had to take this 2K and bring it up to a 12K. And this 47K, I had to drop to a 33K. And then for the the preamp stage here, this pentode stage, the 6SJ7, I had to change the 470K to a 220K. And now all of our voltages are in a good place right now for where they need to be. So I'll demonstrate this here real quick. We'll turn it on, and we'll see how this works. I want to make sure this isn't touching anything. Before I turn it on. And here we go. And I'm going to just go ahead and short the probe to the ground lead like that. I'm going to make a little loop. Let's turn this on. And in addition, I'm going to connect up my RF signal generator now. So I'm going to put out an AM signal. We're just going to do 455 kilohertz. And we're going to do about 300 millivolts. But again, this is an unmatched loop coil. So don't let that fool you. We're not radiating a whole lot because of this. But we'll go ahead and just lay this right on top, as you can see. And let's see. And you can hear. There we go. And there's the attenuation switch, 1 to 1 and 100 to 1. And you can see it's just sitting there. So there's no physical contact, and that probe is actually just picking it up without even touching anything. And there you go. So, and of course, if you were to touch this probe to the actual signal, it would be really loud. It would swamp the whole input of this out. So it works really well. I'm surprised. I mean, I didn't have to, other than getting the voltages correct, it turned out really good. I'll show you some of the voltages now. So if we look at the plate voltage of the 6K6, we have 316 volts roughly. The screen grid is 245, and remember, that's reference to ground, but reference to cathode, you have to subtract the cathode voltage. And our cathode is at 24 volts, so the voltage across the tube is plate voltage minus the cathode voltage. And you can see again 24 volts. If we go to the 6SJ7, the plate, 115 volts. Cathode is about 1.5 volts. And of course, this is going to be negative. It's 0 volts right now, but it's negative with respect to the cathode. On the 6C4, the plate voltage of that is 56 volts, which is just fine. And of course, the cathode is tied to ground on that. And that's all there is to that. It's a very simple little circuit. So there's all your voltages. Everything is stable. You can hear it's just dead silent. Even when I turn the volume up with the probe shorted, it's all the way up. You get a little bit of hum. That's it. Turn it down just even a quarter of the ways down, and the hum is gone. So this is a really quiet signal tracer, which is awesome. And everything looks ready to go. So really, we're down to just let's build the probe. Okay. So this is a little bit lengthy, and I marked it off where I think is going to give us plenty of extra room. So it's a little over 6 inches. So you can see there, which is about 16 millimeters, or 16 centimeters, I'm sorry. And that's just about right, you can see, to hold this. So I'm going to get this is the larger. I have several of these. I don't use this one very much. I use the smaller one most of the time because I'm usually only cutting smaller diameter pipe. And I'm just going to cut through this. Kind of awkward to hold it in front of the camera here. I think this makes a lot neater cut than using a saw, you know, like a hacksaw or something like that. It cuts it nice and smooth. Just takes a little bit longer to go through it. I think we just about got it there. Yep. And there we go. And that leaves that, and then you just take the deburring tool like so. Hopefully it'll fit this diameter of pipe. I don't think it will, but we can try. And then I'll just have to, actually this one's not big enough, so I will have to use a rat tail file and just file it down smooth. Has to be smooth because the stopper has to fit in there, so we want to cut that out. And after a little bit of filing, everything looks good. Okay, let's see if this fits in here now. It should slide right in. Oh yeah, like a hot dog down a hallway. And there you go. And then the front piece will go in here. And there's our probe. I think that'll look good. And we'll even, possibly I can leave this like this, or maybe I will put a coating of heat shrink over it. I don't know yet. We'll figure that one out later. But this all looks good. Okay, sorry folks, but this is all you're going to get is some camera video. I turned down this little button on the lathe, and unfortunately none of the plastic stock that I had was wide enough for that aluminum tubing, so I had to turn it out of wood, and maybe I'll get some plastic later, but I just want to get this project working. This should work fine. And I'm just in the process of drilling the center out for what's going to end up being the probe tip, which is this piece of brass here that I have turned, and I have to finish machining it. We'll do that next. And let's see if I can do this on camera. If I screw up, you can watch me screw it up in real time, huh? Like I said, I don't have it very well centered. This is just a quick hack job. This is not proper woodworking, folks. Alright. And we've popped it through. You can see how it's wobbling a little bit because I'm not. Sorry about that. Okay, I think the camera just shut off because I was trying to hold it with one hand and my finger hit the button. But you can see I basically drilled it through, and there it is. Let's see if our little brass piece will go through there. Let me move this tailstock out of the way. And that looks like that's going to fit in there. That's actually pretty snug. I don't want to push it further in there. Okay, let's get this ready to install, and then this should be ready to take back up to the house. Okay, essentially I'm going to need two hands to do this, but what I'm going to do is, you can see I've put the tip on there, and this back part I'm going to peen out flat to make a solder pad to attach the wire inside. So I'm going to do that off camera because of course I can't hold the camera and do this at the same time. So I'll be right back. Okay, I have the probe together, and I have my AM transmitter, my in-house transmitter on. So I have AM 800, and I have just some oldies that's actually not copyrighted stuff. It's so old that we're allowed to play it. And I just want to turn this up, and you can see just how sensitive this probe is. Now, mind you, there is going to be some 60 cycle hum because things aren't grounded or anything, but here we go. Yeah, just by putting my hand next to that probe, my body is acting like an antenna, and we're picking up the station. So that's how sensitive these probes are when they're working properly. Now, the only issue with it is that you can swamp it out pretty easily. And of course I'm going to have to fix this stopper. It's still a little bit tight. I'm going to have to shave it down a little bit more to get it plugged in there properly. But as you can see, it's working extremely well. So I'm going to put this thing together. I'm going to call it done. Well, there it is, all put together, and this just cracks me up.
Embrace me, irreplaceable you.
Unbelievable. All right. Well, that's it. That's the whole thing. And I think we have another nice piece of test equipment to put on our bench. And hopefully it'll last as many years for me as it did for the last person that owned it and enjoyed it. Definitely a little bit awkward looking probe, but you know, this is not exactly the, you know, it's kind of a cumbersome thing too. So that's just what these were like back then. You know, you have to fit that vacuum tube inside of there. So that's all there is to it. One extra thing that I found is I toyed around with this resistor right here. And I found by increasing it substantially, to actually specifically to 150K, it even got more gain, a little bit more gain. The voltage doesn't change a whole lot. So when you look at the plate here, the difference between that 33K resistor and this 150K resistor is only about 7 or 8 volts. That's it. But this thing really is very sensitive to the voltage that you have on it. So if it seems to be happiest when it's somewhere between 25 and 40 volts. And if you go even a tiny bit above or below that range, it substantially changes the gain of this probe. So it's funny because when I put this anywhere from 150 to 180K resistor, that's where it was at its happiest. If I went one more notch to like 220K or 200K, anything above 180K, it dropped off. And if I got down below like around 100K, it dropped off a wee little bit. All the way down to, and from 33K up to 100K, very little difference. If I dropped it below 33K, it avalanched again. The voltage would go up and there was absolutely no sensitivity. So just something to remember when you're playing around with these grid leak detector probes. This is all new stuff to me. I never really played around with this circuit ever before. So it's very interesting to learn all this. So that's it. And our attenuation works pretty well. The AF just goes right into this jack down here, and all it is just a high gain amplifier. You have this going straight into, well, if you see this going straight into the amplifier here, and it just amplifies whatever it sees there. And then the RF, of course, uses this probe. So that's it. I enjoyed this. This was a lot of fun learning this and reverse engineering it and playing around with the different values and everything. I really enjoyed it. I hope you did too. And there's quite a bit of equipment that came from this person. So I have several signal generators, and I have a couple of contraptions that he built that are really interesting. They're pretty beat up, and I don't know if they're going to be repairable like this one was. But we may look at them anyway and try to figure out what they were. Some pretty strange stuff. So anyway, until next time, I wish you all peace, joy, happiness, and good health in your lives. We'll see you again real soon. And, well, another piece of test equipment for the bench. All right, everybody, take care and stay well. Bye-bye.
Meets the goal of the day. Someone waits for me. Welcome to Coca-Cola Radio Time, produced and transcribed in Hollywood with John Scott Trotter and his orchestra, the Rhythmaires and Bing's guests, Fred Astaire and Peggy Lee. And now, here he is, pushing his way up to the frosty earth and shaking the moss from his petals, the first crocus of spring, Bing Crosby.
Nice piece of verbiage.
Like that, huh?
First crocus of spring.
Yeah.
Ken, you're as flowery as a chef salad in the greenhouse. I wonder if I could get Groucho Marx to give you away on his show next week.
Oh. Spring just brings out the poet in me, Bing.
Well, I don't mind you wooing the muse once in a while, but don't call me a crocus.
No?
I fancy myself more as a proud sunflower, with my head constantly turning to face the sun.
Yeah? Well, with all the suns you got, your head must be spinning like a ballerina.